Target 6.3, I can classify reactions as single replacement, synthesis, decomposition, combustion, double replacement, or acid-base. This part we will worry about later. Acid-base is a subtype of double replacement. Double replacement has three subtypes: acid-base, precipitation, or gas-producing. We'll worry about that part of the target later. Right now we're just going to focus on classifying into one of these three subtypes. The equations take these general forms. Synthesis, direct combination, is another name for that, and also the EOC calls it composition. So there are three possible names for this. I like to use synthesis, but on your end of course test they will use composition. Synthesis means to make something. So that's exactly what happens in a synthesis reaction. Element or compound A and B combine to form one substance. The way you'll recognize a synthesis reaction is there is only one product. You'll never have a plus sign on the right side of the arrow on a synthesis reaction. So for instance, 2H2 plus O2 yields 2H2O. There's an example of a synthesis reaction. Only one product. Decomposition is the exact opposite of that, which I suppose that's why they decided to call synthesis composition, being a form of the word. In a decomposition reaction, you'll only have one reactant, and then it splits up into parts on the right. So you could rewrite this equation backwards: the decomposition of water into hydrogen and oxygen gas. That's an example of a decomposition. Only one reactant. Single replacement, you'll only have a single element combining with a compound. On the right side you'll have a different single element. What's actually happening here is A is taking B's place in the compound. So now A is combined with X on this side and B is alone. You recognize a single replacement because you have a single element on both sides. An example of this may be magnesium plus copper 2 nitrate forms magnesium nitrate plus copper. Single element, single element. Double replacement, you have two compounds that just simply trade partners. A combines with X and B combines with Y. So you never have any single element in a double replacement reaction. Combustion of a hydrocarbon always takes this general form. Any combination of hydrocarbons, carbon and hydrogen, whether it be CH4, C3H8, many of these combinations of carbon and hydrogen, sometimes oxygen will also be attached. The combustion of a hydrocarbon is always the same. You always combine it with oxygen, and the products are always carbon dioxide and water, so these are pretty easy to recognize. The common mistake is to call this a single replacement because it has a single element on the left, but there is no single element on the right, therefore it cannot be single replacement. Also, sometimes people confuse this with double replacement, but double replacement has no single elements, but yet this does. So if it doesn't seem to fit and you don't recognize it right away, check to see if the products are carbon dioxide and water. Check to see if it's a hydrocarbon combining with oxygen. Now, I put this over on the right because we will add this later. In a single replacement reaction, we're going to use the activity series to predict whether or not a reaction will occur. Just because you can write an equation doesn't mean if you actually put the single element into the compound, a reaction would take place. We use the activity series, which is a list of elements in order of most active to least active, to predict whether or not a reaction will occur, and I'll explain that later. In a double replacement reaction, we'll be using the solubility chart to determine whether a reaction takes place. When you do this, you look for an insoluble solid to be formed. If both products that you've predicted are aqueous or soluble in water, then you'll just write no reaction. We'll cover that in a later target. Right now we'll focus on just classifying into one of these 5 types. So we will have a little practice here. Sorry if you saw the answers, but this one, single element or single compound on the left, and it breaks into pieces, so that would be filed under decomposition. This one has a single element, but not on this side. It has a hydrocarbon plus oxygen. Products are carbon dioxide and water, so that is definitely combustion. Single compound on the left breaking up, so that's decomposing or decomposition. Number 4, 2 compounds trading partners. That would be double replacement. Number 5, single element, single element. Single element on this side, single element on that side. Iron took silver's place, so that is a single replacement reaction.